let's start this discussion with a real quick review of cylindrical coordinates. First of all, before we go to cylindrical, let's talk about polar just momentarily here. On the xy plane, if I have a point out here that has coordinates xy, I can also represent that in polar coordinates as the angle theta and a radius r. So this also equals the point r theta. Now from this we get the relationship that x is equal to r cosine theta, y is equal to r sine theta, and we also have the relationships x squared plus y squared equals r squared, and quite often comes in handy to recognize that tangent of theta is simply y over x. Now if I take this point and I move it into 3 space, so here's some point up here, the projection onto the xy plane of this point, sorry, that's supposed to be straight, the projection down here onto the xy plane I can also represent as having polar coordinates. So here's theta and here's r. So if I simply add a z component, I can now represent this point x, y, z in terms of r, theta, and z. So this gives us this relationship where x is still r cosine theta, y is r sine theta, and then we add to it when we move to cylindrical coordinates that z is simply equal to z. So this gives us a relationship that we can use to move back and forth from rectangular to cylindrical coordinates.